Hello, everyone. I am so excited to welcome you to our session today. We are about to embark on a truly awe-inspiring adventure titled A Journey Across the Cosmos. Together, we will travel from our home planet to the very edge of everything we can see. To start, we need to talk about the scale of reality. You see, our human brains are evolved to understand things at a local level, the size of a house, a mountain, or a country. But when we look at the stars, we have to stretch our imaginations to grasp distances that are almost impossible to fathom. Our starting point is Earth. It's a massive world to us, with a diameter of roughly 12,742 kilometers. If you were to drive a car around the equator at highway speeds, it would take you over 15 days of nonstop driving just to get back to where you started. Look at this image of our beautiful blue marble. It feels big, doesn't it? But as we move forward in this lesson, you'll see how Earth becomes a tiny, fragile dot against the backdrop of the solar system and the galaxy beyond. Our goal for today is to build a mental map of the observable universe. By the time we finish, you'll have a much deeper appreciation for just how vast space is and where we fit into this grand design. Are you ready to begin our ascent? Let's begin our journey right in our own backyard by looking at the relationship between Earth and its closest companion, the Moon. While they look close in the night sky, the reality is much more spacious. When we talk about the average distance between these two celestial bodies, we are looking at a truly staggering number. That is roughly 384,400 kilometers. To put that in perspective, you could wrap the Earth's equator nearly 10 times with that distance. It's not just a quick hop across the street, it's a massive void. Take a look at this chart. It visualizes the diameter of Earth compared to that total distance. You can see how the vastness of the space between us dwarfs the actual size of our world. Now, here is a concept that often surprises people, the planetary gap. This is where our intuition about space usually fails us. Believe it or not, if you were to line up every other planet in our solar system, Mercury, Venus, Mars, the gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune, they would all fit side by side inside that gap between the Earth and the Moon. It really highlights how much empty space there is, even between the closest objects in the cosmos. Building on what we just covered regarding the Moon, let's zoom out further and look at the scale of our entire solar system. As you can imagine, the distances become so vast that our standard units of measurement start to fail us. To make things manageable, astronomers use the astronomical unit, or AU. 1 AU is roughly 150 million kilometers, which represents the average distance from the Earth to the Sunday. It serves as our standard cosmic ruler for our local neighborhood. But space isn't just about distance. It's about the incredible dominance of our star. The Sun contains a staggering 99.8% of all the mass in the entire solar system. Everything else, all the planets, moons, and asteroids, is just a tiny fraction of a percent. Now, these numbers are hard to truly grasp, so let's try a visualization we call the marble analogy. It helps bring the solar system down to a human scale. Imagine the Earth is just a tiny marble. In this same world, the Sun would be a large exercise ball, about a meter in diameter, but the real surprise is where you'd have to place them. To be accurate, that marble Earth would need to be 110 meters away from the exercise ball Sunday. That is more than the length of an entire football field of empty space between them. It really highlights how much of our solar system is actually just space. Welcome to our scale model of the solar system. Here we will journey across billions of kilometers to understand the true awe-inspiring scale of our cosmic neighborhood. We begin at the Sun, a massive star that holds 99.8% of the solar system's mass. Every planet you see is dwarfed by its immense size. The inner planets Mercury, Venus, Earth, and Mars are relatively close neighbors. Notice how compact this region is compared to what lies ahead. As we cross the asteroid belt to reach Jupiter, observe the massive gap. In space, distances are often measured in astronomical units, U/U, where 1 AU is the distance from Earth to the Sunday. Use this slider to speed up time. You'll see the inner planets zip around the sun while the distant gas giants move with a slow, majestic grace. Finally, let's pull back to see the entire system. From here, the outer planets like Neptune are so far away they seem lost in the void, highlighting the incredible emptiness of space. Building on the proportions we just explored, we've reached a point where standard units like kilometers or even astronomical units aren't enough. To measure the vast, awe-inspiring empty spaces between stars, we need a much larger ruler, the light year. This measurement is based on the universal speed limit. Light travels at an incredible speed of approximately 300,000 kilometers every single second. At that rate, you could circle the Earth 7 times in the blink of an eye. When we multiply that speed by the number of seconds in an entire year, we get this staggering figure, roughly 9.46 trillion kilometers. This is what we define as 1 light year. It's important to clarify a common point of confusion, even though it contains the word year. A light year is a measurement of distance, not time. It's essentially telling us how far light can travel in a year. To put this into perspective, look at our nearest stellar neighbor, Proxima Centauri. It sits 4.2 light years away. That means the light we see from it tonight actually began its journey over 4 years ago. Now that we have our yardstick, let's look at the massive structure these stars call home, the Milky Way. Building on that sense of scale, let's take a closer look at our galactic home, the Milky Way. This isn't just a collection of stars, it's a massive rotating city of light that contains everything we've ever known. What you see here is an artist's rendering based on our best data. It's a barred spiral galaxy, characterized by this bright central bar and these majestic winding arms of gas, dust, and stars. From this top-down perspective, we can truly appreciate the symmetry and structure of the disk we live in. Remember the light year we just discussed? To give you an idea of the size of this structure, it would take a beam of light 100,000 years just to travel from one edge of the galaxy to the other. Even at the speed of light, it's a journey that spans the history of human civilization many times over. Inside this vast space, there are anywhere from 100 to 400 billion stars. Our sun is just one ordinary star among those billions, each potentially hosting its own system of planets. And where are we in all of this? We aren't in the crowded, energetic center. Instead, our solar system sits about 26,000 light years away from the core, tucked away in one of the quieter spiral arms. It's a perfect, stable spot for life to flourish. Just to keep these numbers grounded, keep in mind that a single light year is nearly 9.5 trillion kilometers. It is a distance so vast that traditional numbers almost lose their meaning. Now that we know our own neighborhood, let's see who our neighbors are in the local cosmic group. Building on our look at the Milky Way, we now zoom out even further to meet our galactic neighbors. Just as we have neighborhoods on Earth, galaxies exist in clusters, and we belong to one called the local group. To understand these distances, we must use the light year. Remember, this is the distance light travels in a single year, nearly 6 trillion miles. When we look at galaxies, we are looking across trillions upon trillions of miles of empty space. Our most famous neighbor is the Andromeda Galaxy. It's a magnificent spiral similar to our own, but it lies 2.5 million light years away. That means the light we see from Andromeda today actually started its journey toward Earth before humans even existed. Take a look at this data. Beyond Andromeda, we have the Triangulum Galaxy and the Magellanic Clouds. The Magellanic Clouds are actually satellite galaxies caught in the gravitational pull of our own Milky Way, like moons orbiting a planet. The local group contains over 50 galaxies in total, spanning a region of space about 10 million light years across. It's our small corner in an unimaginably vast universe. Ready to see how this scale looks in motion? Let's move into our simulation. Welcome to our cosmic journey. We are about to explore the universe across 45 orders of magnitude, from the subatomic to the infinite. This slider is your engine. Moving it just one step changes your scale by a factor of 10, a power of magnitude. We begin at 10, 0 meters, the scale of a human being. From here, every step right makes you a giant, and every step left makes you microscopic. At 10, 21 meters, we see the Milky Way galaxy. It's a swirling disk of billions of stars, so vast that light takes 100,000 years to travel from one side to the other. Zooming out further to 24 meters, galaxies appear like tiny dots of light organized into a cosmic web, the largest known structure in existence. Finally, we reach the edge of the observable universe. This represents a distance of nearly 93 billion light years, the limit of everything we can possibly see. Now, let's dive inward. At -10 meters, we reach the atomic level, where the physical laws that govern our everyday world begin to shift into the quantum realm. Having just zoomed into the tiny quantum world on the previous page, we now expand our perspective to the ultimate limit. This is the observable universe, the sphere containing everything we can possibly detect from Earth. Remember our definition of a light year? It's the distance light travels in 1 year. At these scales, even the vast distances between stars we discussed earlier seem like tiny steps. The total diameter of this visible sphere is a mind-bending 93 billion light years. It encompasses every galaxy, every star, and every atom that has had enough time for its light to reach us since the beginning of time. Now, here is a puzzle. If the universe is 13.8 billion years old, how can it be 93 billion light years wide? This is because the universe has been expanding rapidly. While light was traveling toward us, the space behind it was stretching, pushing the source of that light much further away than when the journey began. The very edge of our vision is marked by the cosmic microwave background, or CMB. This is essentially the wall of the first light ever emitted. Beyond this, the universe is opaque to our eyes. It represents the ultimate horizon of human knowledge. We have reached the final stop of our journey today. From our first look at the moon's surface to the edge of the observable universe, we have covered an incredible amount of ground and space together. Take a moment to recap the sheer scale of what we've seen. We began with Earth, a planet 12,000 kilometers wide, and expanded our view until we were looking at a universe spanning 93 billion light years. It's a leap in scale that is almost impossible to visualize, yet here we are, having explored its depths. And remember, as we discussed when we moved beyond our sun, we use the light year as our cosmic ruler. It represents the staggering distance light travels in just 1 year, nearly 10 trillion kilometers. This brings us to a change in perspective. When we see Earth as that pale blue dot suspended in a sunbeam, it humbles us. It reminds us that scientific inquiry isn't just about numbers. It's about understanding our delicate place in the vastness. I'd like to leave you with this beautiful thought. We are a way for the cosmos to know itself. By studying the stars, we are the universe, looking back at its own history. Thank you all for your incredible focus and curiosity during this session. You've done a wonderful job grasping these massive concepts. Keep looking up.